This video we're going to talk about the real number system, which is just how we classify all the numbers we've ever learned about. So when we talk about real numbers, we differentiate between either a rational number or an irrational number. Both are considered real numbers, but a number is either identified as being rational or irrational. So let's start with the rational numbers first. We're going to start in the yellow box, which are natural numbers. Natural numbers are numbers that you have been learning since you were little. The numbers you learn naturally. And what's the first number you learn? Well, naturally you count with 1, 2, 3, 4, and so on. Okay? You don't start with 0. 0 is not a natural number. Then we move on to the green box, which are whole numbers. Now, whole numbers are all the numbers that you learned when you were very, very little, but now we're going to include 0. So 0, 1, 2, 3, 4, and so on. So, for instance, the number 4 is classified as a whole number, and it's also a natural number. But 0 is a whole number. Moving right along, then we have integers. Integers are all the positive numbers and 0, but as well as their opposites, so negative numbers as well. So -3, -2, -1, 0, 1, all the way up. Those are integers. Think number line. All of the numbers that you would put on a number line, those are called integers. Then we get to rational numbers. Now, rational numbers are all the integers, all the whole numbers, all the natural numbers. They're also all the fractions. The definition of a rational number is that it can be written as a fraction. So anytime you see a fraction, it's definitely rational. Okay? We're also going to put perfect squares in here. We're also going to put terminating decimals. Now, the word terminating, like the Terminator, kills you. Terminating means ends. So decimals that end are rationals. But decimals that do not end, they go on and on forever, like pi, those would be irrational, which brings us over here. So irrational numbers are non-terminating. They never end. Non-terminating decimals. Sorry, it's a little messy. Okay, if perfect squares are rational over here, we could say that non-perfect squares are irrational. Okay, so now let's look up at the top here. I'm going to change my color. Let's use blue. The first one we have is 0. Is 0 rational or irrational? 0 is definitely rational because it falls in the left side of the chart. Radical 16. Well, what is the square root of 16? 4. And 4 is a whole number, so perfect squares, again, are rational. Let's take a look at radical 2. What's the square root of 2? Is 2 a perfect square? No. So this one would be classified as irrational. Let's go over here to something easy. Number 10. 10, is that rational or irrational? Well, that's a whole number. It's also a natural number and an integer, so therefore it is rational. Let's go back over here to another easy one, -3. -3 is a integer, okay? That means that it's rational, right? All negative whole numbers are rational. 1/3. Well, we said that fractions are rational, so it's rational. Square root of 81. Is 81 a perfect square? Yeah. 9 times 9 is 81. So this is definitely rational. Pi is the most famous irrational number because it never ends and it doesn't repeat. It doesn't have a pattern. So pi is definitely irrational. 2.45 repeating, okay? 2 and 45 hundredths, that's repeats. The 5 repeats, that's what that little symbol up top means right here. So this is a rational number because repeating decimals that have a pattern, 2.4555555, those make sense. They are rational. This number is a never-ending decimal. That's what those 3 dots mean. And it doesn't seem to have a pattern. So this one is irrational. Okay? We'll put that over here. And then the last one I want us to focus on is 3.14, 3 and 14 hundredths, which is what we use to abbreviate pi. But in this case, it is a terminating decimal. It ends. Okay? This is a rational number. Okay? So the symbol for pi is irrational, but the abbreviation is rational.